So we know that you use the stack. They use stack for ints, and for conditions they do state tree open, tree close. And it kind of like makes sense. I mean, they first generate parentheses and that the n equals to 3, and so I just think that n equals 3 is just linked to the 3 OP and 3 CL, um, and it just tells me that it just that they link, and when n equals 3 and they do actually state generate parentheses. I mean, generate parentheses is basically this bracket stuff that's going on, and when n equals 3, I think they refer to the stack per se. So when they say n equals 3 is referring to 3 sets of the brackets that's actually do happening. So what's gonna actually happen is that we gonna have this n equals to 3, and that so I think the question I ask right now is why stack, and does the first question, if you ask that, I think is to ask whether like do actually order to actually matter. So if I do zoom into the detail example, is that that why can't I open and then close again? So as you can see, they don't actually have that thing that is going on. So we already can tell that the order do actually matter. So another conditional statement is that um, on another hand, order do actually matter. So order do matter because you see this one so first and foremost, you see the one over here. So one is that the next bracket, it can't be closed, right? So it can't be closed because order do actually matter. You always have to the rule is also always this, that you got to open and then close. So like the basically the left side one or must be open. So say for example this one, it has a open, okay, then I can do a close. But if this condition is not actually met, you actually cannot. So a second one, which is this one, another open, right? So yeah, you can do a close. It always must have like a the left side must always be the opposite parameter, right? So and this one I mean this A just explains a lot to us about that. And and for to argue like what is actually the opposite side of like things, that what you this is what you can do, what you can't do is basically you 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 open and then okay you got a close, right? You can't close again, so this is not good, this is bad. So another one thing is that you cannot start off with a close as well, this is not good as well. So as you can see, if for A it's basically that for every open it always have like a when you put in the close, the left side is always an open. And for B, and one more example is that you open and then you close, right? So for B, it just show you that like you can't initiate the close when there's no open at the left side. Similar for this, you can't close when there's no open at the left side. So when you talk about the instruments over here, yes, sure, you actually discuss about why do we actually use stack, and you will always argue that okay, why not us like use a brute force way to actually try to actually solve the problem, which is something that we actually can think a lot about. So honestly speaking, don't actually have a way to actually think of how to use as actually the brute force way to actually think of this problem. So maybe say that we are getting a set of three, right? So most likely what I think is that the brute force way, the first one that I actually can do is that um, definitely I do this open 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 and then close 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 close, because I mean it just obey the law, right? That there's a total number of set of like n equals to 3, which is having these 6 elements that actually being involved. So the next one I probably will actually try when I do a brute force is that I want to flip the last one out. So open open close close. So as you can see, the question now is this: is this sort of like valid by just flipping one of the item around? So this one I close. I actually don't know how to actually read this one. Let's take a look. Open close. Okay, so does it actually remove this and then remove this and then remove the last one? Yeah, I think so. So this is kind of like valid still. But the thing about brute force, it doesn't actually know how to read things. I just feel that it will start off maybe say like this, and this is obviously wrong because you don't follow the condition, and I just feel that the brute force will actually run through this and give a very redundant entry, I'll say. And I just feel that overall the brute force will have a lot of this sort of like redundant entry that's used up for nothing. Whereas stack, you already state all these different conditions, so you are very efficient in a way whereby you don't have this redundant entry. Because so um, if we were to actually argue is that for stack we have conditions that say, so this one we can actually argue that we require a less number of like entry needed. As for brute force, you have more entry that's actually being used. And talking about the number of entry, you are actually talk about the number of space that you actually take up for overall. So a lot of like all this redundant entry. So the next one, probably you can flip it around. So you can say close, close, open, close, and then open, open. So yeah, this one remove, but these two that actually don't actually meet. Another redundant entry, so it leads to even more entry that's required to actually check the overall scheme of things. So I mean that's why it just running through the brute force way just re-emphasize on the beauty of stack having these conditions that actually fulfill the criteria for the question specific, right? So by having said that order do actually matter, that you got to always be a tree open, tree close, sort of like a situation stack, right? Like there's I don't necessarily another point I want to maybe say argue is that how come your stack have the brain to actually say that when to put in the open and when to actually he have like this smart way of like saying that you know when to put the open, when to put the close accordingly. But how come your brute force don't actually know? Does can we actually make the brute force smart enough not to actually put all this redundant entry whereby it states that it will always go by the open first, you know, because we do know that open and close, the close got to be left side with open to be able to end a loop, and then so on and so forth. Are we able to actually make at the end of the day, are we actually able to set this brute force to be smart, to be able to actually open and close accordingly, like how our stack is actually doing? That's the question I like to actually ask, you know. So I think what we are fundamentally trying to ask over here is that are we then able to actually implement conditions to our brute force way of doing things? Maybe say I want to add this condition of like having this tree open and tree close. Are we able to actually fulfill that? That's the question mark that I'm thinking about. If I am actually able to actually do that, right? So I actually cut down a lot of like this redundant entry. But I think one thing for sure is that because this, I think, in my opinion, at least for now, I feel that the instrument brute force is able to do this, but it's not able to actually do this order thing, because I feel that order is a stack specific properties that what the stack actually have as a form of like properties, that he established this rule that okay that it will actually remove the last item based on what item that you put later, right? So say you have open, okay, nothing happens. Open, okay, nothing happens. But if you put an open close, okay, stack will actually remove the item immediately. And when you come to over here, is that open close, okay, automatically the stack will have, based on its properties, last in first out, it will start to remove elements accordingly immediately. But when you put it into the brute force tree, I most likely you're gonna use a simple array. I mean, maybe say a simple list, and it will hold like just the most basic property. It won't has this last in first out property, so it won't actually do anything to it, and that it won't have established this conditional state property that is stack specific. So for the condition for brute force, you can't do that because you're just using a very much basic array, and it will have this all basic property which doesn't have this ideal to have this order property that's been implemented and to actually carry that out, I feel. I feel like what actually this y condition do is that, okay, we play it out for the flip side of like the condition of y. So it's at z, right? So z is saying that, okay, close must always have more than open. So okay, having said that, So I definitely open up my close first and then follow open, and then close, close, open. Obviously, these two entries is the false one. But if we were to actually look at the while condition, if like close is always less than open, that means I need to start off with open first, because my open must always have more. Okay, this is sort of like a valid. Open is also still valid. But this sort of like a 3 open 3 close sort of thing. It just tells us that the parameter must always be 6. But for this one, it's so much more talking about, because we use these two properties, right? So these two collision sets. But let's move on to why. So we talk about saying that if say close must be the open must always be more, right? I do this open close, it's still sort of like valid. I do this open and then I follow by close, it's still valid. So I just feel that whatever this property, this condition is actually doing is really useful, and obviously you do need to actually and that's how they actually compute it in a computational way. I feel like this is definitely entering easily into the spell 2.6 domain of things. It may be talking about spell 2 or spell 2.5, but yeah, it may be talking about spell 2 specific, but I just feel like, wow, this makes so much sense that the computer actually need this condition to be made. So one thing on top of my head, I was actually also thinking that this one, so this y, okay, let me think. This y and the x, I feel like they work hand in hand to be able to actually carry out this operation to be smooth. So because I feel that you can't just have this one property, which is the last in first out, to be using, because say if you you open and then you start doing, say you have this open close, right? It still obey the law of last in first out. But what you actually need to actually have accompanied with this is the y, so that you can actually make sure that they are going in the open close. And similarly, if you were to actually argue that, okay, maybe I can just bring in the condition of saying that just require six parameters. But if you were to see actually the z, you start off with close open, it also does obey the A, B, C, D, L, M, N, O, V, Q, R, S, T, U, V, W, X. So you see that Z is fulfilling whatever W is asking me to do, you know. Z is closing and open, it obeys the W. It close open, it also obeys X. So the missing link over here for Z is basically saying that you need to have this Y thing. If you don't have this Y, you won't be able to actually put in the right order of like items. So I just believe that this Y and Z things is settling for the order of things. So when I talk about last in first out, I believe that we are following the rule of like removing elements. And then for the order, what we actually need to do to be able to have the order is basically that we need the close and then the open. Close less than the open. And then when we actually talk about the number of items. So if we do talk about number of items, we are actually using the so-called a 3 open 3 close condition. So basically each of the condition is being met by having sort of like a rule that we pass on, that we establish. So for order, we establish with the close less than open. And for the remove of item, we use the last in first out to actually address that. I mean, now at least we talk quite a bit about things. So maybe we can actually zoom in or play it out. I think it's really important to actually play out. So before we first set off our foot to empty, and then we put on the open. The reason why we put on the open is because we go to down to Z and say that okay, my close must always be more than the open. We go to Y, close must be less than open. So intuitively speaking, we started off with the open. And while trying to actually obey all these conditions, I proceed on to actually put on my next parameter. So I open and then I open, right? So the thing is, the reason I still can do open because first and foremost, Y isn't part of my conditions because I know that I have an open already. So no matter what, I can actually throw any card out for my next move. That's why I can either throw open or close. Doesn't matter because I know my previous card is already open. I already meet this condition. So no matter what, I can throw for my next move. So therefore, both move I can actually throw. So another condition to actually set for ourselves is that have we meet W or not? And the answer is like we don't need to consider that until like further on down over this area. Then I need to consider that. So W is not within my picture when I'm doing when I'm planning for the next move at the open stage. So Y and W is out of the stage when I've thrown in open. So the next thing I think about this is that there's always this built-in function that we actually build, whereby the moment we throw in like a closed loop, which is open and close, the opposites, if we throw opposites, we straight away am able to actually have like a built-in function to actually sort of like a vacuum cleaner that actually cleans up this data for us. And this is, I think, because I just feel that like there's like a clear wall in between that says that a very fine boundary that says that okay, this one, it falls under the category of like being of like a instrument specific. Okay, it's an instrument property specific, like it's an instrument conditions specific. But for here, I just feel that whatever we talk about Z, what we talk about Y and W, I feel like it's sort of like established condition established, right? If it's condition established, it means that something that we actually we establish a rule so that it can actually that for us to actually sort of like obey in the process of like trying to play things out in the playing field, right? And I just feel that last in first out of like having this needing to actually help us to actually remove items, I just feel that it's a condition instrument specific sort of like a property, and I just want to be able to like distinguish between these two, because these two are completely different items, right? So like because as we were actually discussing, so maybe say we have this we meet until the condition of like we play out, we meet the opposites, the instrument is gonna like activate itself, but is that something that we actually considered on the opposite end, which is saying that does our W or Z, do we have to actually check before we actually pull out the stuff? I just Okay, so I like to actually put it this way. Maybe say this condition established is so much to do with, okay, it limits on what cards are you able to actually play out, right? But for condition instrument specific, it's so much more about like, okay, you throwing the card, like the system will actually run itself to actually do its thing, right? So that one is like talking about how the system is gonna like react to based on your plays. But for conditions, conditions established, I just feel that it's about like the uh, the second thought that you're gonna have before you play your cards. So one, I think over the right side, I feel it's very much to do with first and foremost, we glad to be able to come here to actually talk about these specifics, which is basically this is before basically is saying that um, before we play our cards, things to actually consider. But for here, it's talking about after. So after we play our cards, what's gonna actually happen? What's gonna actually happen? Is this a stack? Uh, because you use stack, right? It's just gonna have this property of last in first out. So if you put opposites, I'm gonna like totally remove both of your these items. That's what's gonna happen. But here, before you actually play your cards, these are the stuff that you actually have to actually consider. That you have to actually follow the rule of W and Y. Okay, okay, I now know. Okay, so I place the open, and then okay, now I'm open. Following the rule of the W and the Y. Okay, I can play any card right now because I'm obeying both these Y, W, Z rule. So my next play, the moment I play my open for my first turn, I can play either of the cards, right? Doesn't matter. So that's how I think about this one. This is really wonderful because I think that this is something that was really hard for us to actually think and to be able to think through to actually establish and actually come up with a solution specific for this one. So I'm really glad for this one. Really thankful. Obviously, what we like to talk about is basically maybe in the brute force, we didn't really both the brute force and the stack, we didn't go deep enough to actually talk about like the big O of like operation of how much it actually takes to actually conduct all this thing. But what I can just say is that since I just feel that the brute force will definitely easily become a n big O of n square time complexity, whereas for stack, I'll say big O of n time complexity. That's my guess. But I think just before talking about big O time complexity, it's so much more important to actually learn about like the mechanism of how each of these instrument do work, right? So for brute force, we sort of like narrow it down that say that we may end up like this one, but I just feel that for condition established is that you can be established to no matter what instruments you actually add into. What comes into play is this condition instrument, which is that do you actually have like this instrument to make you to have this last in first out as like the after conditions for you to actually set. Because I think I just feel that condition after it's it's the thing, it's the only thing that actually plays a part into making your big O of time complexity to be much more efficient, I feel. So maybe when we actually argue, we don't actually argue about condition established. We argue a lot about the condition instrument on how it actually gonna affect our condition instruments over here. So maybe to actually argue for the z and the y in these conditions, I just feel that for y, whenever the computer sees this, what they so first and foremost, both sides share the same exact elements, and what's actually how the list is gonna react, and we're gonna see how the stack is gonna react. So for list, it sees all this parentheses, and it's like okay, but for stack, it really starts removing the items. It's an open close. Okay, I see something that I actually need to remove, and the list see these items, it sees the brackets, it's like okay, but for a stack it's actually okay, it's an open close, I'm gonna remove, open close, I'm gonna remove, open close, I'm gonna remove, using the built-in feature of last in first out, right? So now we talk about at the end of the day, if we say that for the stack is that okay, if we know that the item has like it's empty, so if it's empty, therefore I will say that the item, it's a valid parenthesis, right? But for list, I just feel that you got to actually be able to pre-establish say that okay, these are the items that is acceptable or not. So these are, so maybe I can say that I can refer this item to maybe say a dictionary per se, that say that okay, if you meet this certain conditions, saying that oh, I have this list of items, the correct ones. So is it according to my dictionary of like, so I need to check with my dictionary saying oh, is this item part of like the dictionary list? Oh, okay, then this one is a tick as a correct one, and I need to check again for a dictionary, and it's okay. And the thing about establishing just another dictionary to just to actually check, maybe even creating this thing, it maybe it really starts establish a new space complexity to be big O of n, just to be able to use this to actually do a check. So I do actually argue that maybe say maybe say for X, you just have to check the item, is it empty or not. But for W, you have actually to cross check with something else to check whether this item is valid or not. This is like a possible way of things, and I believe is most likely for it to make list and also like a basic property to be so troublesome, as opposed to stack. For stack, you just need check empty, done. So that's, I think that for the argue between the W and X. So I discussed maybe say the play out for now. Yeah, so let's play it out. Woo, play it out. Yo. So I opened, and then same thing. Before I play my cards, I need to think of the conditions. Therefore, I can put the open and the close. Before I play the card, I can put in the open, and then I can put in the close. Before I play the card, I do a close, and then this one most likely I can close, and then I can either open and I can play the close, right? So open and then close. But this one, before I play the card, I can play your opens, and this one I can put the open and the close. I believe it's gonna draw one over here. Open, close, open, close. Yeah, that's what I believe. So yeah, yeah, pretty much it. The thing about when I play it out, whatever I actually think a lot about is basically condition condition before. There's so much to do with condition before. Condition after, it's so much about basically what the instrument after is gonna do. So whatever just now we actually play out, we only think a lot about like the condition before, not so much about the condition after. What condition after actually comes out with is basically after our play out. So after we play out, okay, this is what the condition after is gonna do. It sees an open close, okay, I gonna remove you. I see an open close, oh okay, I gonna remove you. Open close, oh I gonna remove you. Open close, oh I gonna remove you. Open close, I gonna remove you. Open close, I gonna remove you. Same thing. Open close, open close, open close. This is what condition after is gonna do. And basically during our play out, we only think a lot about our condition before. Condition after, it's what the system is going to do after you do the play out, which is it's going to remove these elements, remove, remove. So at the end of the day, we actually come to this stack place, the X area, where we say that, oh, my stack is empty, therefore it's valid. And yeah, and if you don't use this stack, if you don't use this condition after, you got to face the consequences. What's the consequences? You're going to be at W. You're going to be at W. You're going to have like all this list, and you're going to be like, oh my god, I got so many of these items to actually check. I need to actually cross check with all this dictionary, all this fuzziness, all this busyness. That's actually extra steps that's required for you to actually check, as opposed to just having a stack that's already built in featured for you to actually remove. And then all you just have to do is to check empty or not. So yeah. Yep, I think that's that. Everything comes to an end.